All right, guys, time to start part two. Sorry I broke it into two. It's just a little bit easier that way. All right, so when we have ionic compounds, okay, we just learned that I can have a chemical formula, right? But what happens, right, if I am given a name instead of the formula, right? So my goal of ionic bonding always is to make a neutral compound, right? We saw this, right? If I had an Na plus, Cl minus overall, when they come together to form NaCl, it is neutral because my positive and my negative charges have to cancel out. Okay. And there's a really simple way to figure all of this out, but you do need to know the charges of each element that we talked about yesterday, right? We find them on the periodic table. When we have a name and we need to now determine a formula, okay, we have a couple steps. First, I'm going to write down what my cation and my anion are with their relative charges, meaning if I have Na, I know it's an Na plus, okay? After that, I have what is called swap, drop, and chop. So I'm going to swap my charges, I'm going to drop my charges, and then I'm going to chop my charges, meaning I'm going to swap the charge of each individual ion, I'm going to drop the charge to the other element, and then I'm going to chop, meaning simplify. Okay, this can also be known as a crisscross method. So some examples I have here, right? If I have Ca2 plus, F1 minus, right? I swap my charges at the same time I'm dropping my charges down to their subscripts. Okay, so I would have a Ca1, F2, and then chopping means I simplify, right? We said that if I have a subscript 1, I don't need it. So I'm going to have a CaF2. Okay. Over here, I have Mg2 plus and 3 minus, right? So swapping and chopping, right? I'm crisscrossing them. The 3 comes down here to Mg. The 2 comes down here to N. And so I can't simplify this any further. I'm going to have Mg3N2. Okay. Al3 plus, P3 minus, right? Swapping and chopping, or swapping and dropping, I'm going to get Al3, P3. And I can simplify this because they're the same number, right? So if I do 3 divided by 3, I get 1. So I'm going to have ALP, right? So let's look at an example, okay? Step 1, okay, says to write out my cation and my anion with charges, right? So if I have aluminum bromide, okay, my cation is always going to be the first element, aluminum. Okay, and aluminum, I know from talking about it yesterday, it has 3 valence electrons. Oh my God, 3 valence electrons. So I want to get rid of those 3 electrons. So I'm going to have a 3 plus charge. Okay, anytime I have an ionic bond, my anion is going to end in "ide," right? So bromide is actually the element bromine, right? I changed that ending to "ide" because I have an anion. And so bromine, I know, has a Br1 minus. Okay. Once I write out my cations, then I can swap, drop, and chop, right? So when I'm swapping / dropping, right, my 3 plus gets dropped over here, my 1 minus gets dropped over here, and I can drop the charges, the plus and the minus. So I'm going to have Al1, Br3. Okay. And then when I want to simplify it, right, we said if I have a 1 here, okay, I can just get rid of that because if I have a 1, I don't need it in my formula. So my overall formula for the name aluminum bromide is AlBr3. Okay, let's look at another example. We have magnesium oxide, right? Step 1 is to just write out my cation and my anion again. Okay, so magnesium, right, is my cation. The first one's always my cation, and I know it's Mg2 plus. Oxide, okay, and I'll give you a hint in your notes. There is a "ide" ending chart, so check it out. If I have oxide, I know that it's the element oxygen, and I know oxygen has an O2 minus charge. So when I go to swap, drop, and chop, right, I know I am swapping those 2 plus and the 2 minus, and I'm dropping the signs to get Mg2O2, right? And now the chop part is just to simplify. And because I have the same number here, right, I can divide them each by itself, right? 2 divided by 2 is 1. 2 divided by 2 is 1. So my overall formula is just MgO, okay? What I want you to do right now is I want you to pause the video and I want you to do these 3 practice problems in your notes. If you have questions, call me over. All right, so now that we have learned how to take a name and create a formula, let's do the reverse. Let's take a formula, right, and now give me the name, okay? And I have 4 steps. First is I write the name of the cation, then the name of the anion, then I replace the ending of my anion with "ide," because I said anytime I have an anion, it is referred to as an "ide," okay? And then I combine the names. All right, and we have 2 examples that we're going to look at. Luckily for you, you have this ginormous chart in your notes, and so you can refer to this if you get confused on what the element becomes, okay? Right? So let's look at K2O, right? My first step, right, my steps I listed up here, is to write the name of my cation, okay? So my cation here, right, K, if I look on my periodic table, is potassium. Then my name for my anion, O, is oxygen. Step 3 is then to change my anion to an "ide," right? And so if I look at my chart and my notes, I know oxygen becomes oxide, and then I combine the names. So K2O, all it becomes is potassium oxide, okay? Notice how I do not include any part of the subscript or the charge, okay? Let's look at MgO, right? My cation's magnesium. My anion is oxygen. I change it to "ide," making it oxide, and it becomes magnesium oxide. All right, again, notice no charges are mentioned, okay, and no subscripts are mentioned, okay? The reasoning behind it is every single time I have a magnesium, I know it's 2 plus. Every time I see oxygen, I know it's 2 minus. So I don't need to include those, okay? So at this time, pause your video and do these 4 practice problems. Again, if you have questions, raise your hand. I will come over to you and I will answer those, okay? All right. Now that you guys have completed your notes, I told you how we're changing this up a little bit. So here is what I want you to answer in your summary, okay? I want you to reflect upon what you did today, and I want you to answer the following questions. How can you depict an ionic bond using electron dot structures? What happens to electrons in an ionic bond? How can you name an ionic compound if I give you the formula? And how can you determine the formula, okay, given the name? So pause your video to write your summary, okay? Take about maybe 5 minutes and come back. All right, now that you guys are done with your note process, here's what we're doing for the rest of the class, okay? You're gonna have to complete your practice worksheets, okay? It's a 2-side page, okay? Front page and a back page. For both sides of the worksheet, cross out number 19 and number 29, okay? So you are not to do 19 and 29, okay? I will have the solutions up at the front of the room, so check those out once you're done. And then once you feel good, use your notes to complete the Mastery Connect quiz. I will put the code on the board and on Google Classroom. All right, so that is your task for the rest of today.